Geometry Chapter 10 Lesson 2, and I'm going to do a number of examples where we determine the area or a missing value in either a trapezoid, a kite, or a rhombus. In the figure that I have here, it tells me that I have a rhombus, so that tells me which formula I need to use, and the formula for the rhombus that we learn is that the area is equal to 1/2 the diagonals multiplied together. So that means I need to determine the length of BD, which is a diagonal, and then the length of this segment here, which is a diagonal. And I want to remember some things about diagonals when I'm looking at this. The diagonals are perpendicular, so all of these little triangles in here are right triangles. Let me use a different color here, hopefully make that out. So this triangle that you see right here is a right triangle. This triangle here is also a right triangle. And then this triangle here, and this triangle here. So all of those are right triangles, which are going to allow me, or give me the ability then to maybe determine a missing length that I may need by using something that I know from my past, Pythagorean theorem, 30, 60, 90, 45, 45, 90, or maybe trigonometry. So again, I accidentally erased that, so let me go back. The formula I know is 1/2 the two diagonals multiplied together. So what I need to figure out as I look at the diagram are the diagonals. Well, I'm only given the measure from here to here is 12, but I know that in a rhombus the diagonals bisect each other, so this length here has been cut in half by this one. So if I double 12, one of my diagonals is going to be 24. So I can substitute in one of my diagonals. I'm having trouble writing here. So I'm going to have 1/2, and then one of my diagonals is going to be 24 meters. Okay. Now the other diagonal goes from here to here. The problem is I don't know the length of this segment or this one or the whole thing. So what I want to do then is think about, well, I know I have a right triangle here. Can I use something to help me figure out this length here, or maybe the entire length? Well, I can use this right triangle, and I know that Pythagorean theorem will help me figure out the length. So if I call this, let's just call that x for right now, I can use Pythagorean theorem to figure out what that is. So x squared plus 12 squared is going to equal my hypotenuse squared of 15. So x squared is going to be 15 squared minus 12 squared. And so x is going to be the square root of 15 squared minus 12 squared. Now you could calculate that if you wanted to. Let's see, we'll need to do this by hand because I don't have my calculator with me. 15 squared is 225, and 12 squared is 144. So that's going to give me the square root of, let's see, 225 and 144. Let's see, 50, that's 75. And 6 is 81. So that's the square root of 81, which is then 9. So I now know, using Pythagorean theorem, that the length from here to here is 9. I need the diagonal, which would be the entire length, so this would also be 9, because again the diagonals bisect each other. So that's going to be 18. So I then have 18 meters, and now I simply multiply these together. Because both of these are even, I can take half of either one. So I'm going to take half of the, let's take half of the 18, so that's 9. So 9 times 24 then, so that's going to be 180, and then 36, so 216. And then meters times meters is meters squared. So the area of this rhombus is 216 meters squared. And let's reveal, let's see if we did that one right. And we do have the correct answer. So again, choose the formula, know what those values represent in the diagram, and then use what we've learned from previous lessons to calculate the values that we need for our formula. Here I have a few trapezoids to do. Let's go ahead and do number 6. There is no number 6. I was looking at this 6. Let's do number 8. So as I look at the figure, I know what my formula is going to be, or I choose the formula for the trapezoid, which is 1/2 the height, base 1 plus base 2. Then I need to look at the diagram and see what I know. The height again is the perpendicular distance between the two bases, which is unknown. One base I know is 6. The other base I don't know, so I'm going to have to figure out both B sub 2 and H. So it takes a little bit of just putting some pieces together. This part of the trapezoid after drawing this height is a rectangle, and I know that the opposite sides in a rectangle are equal, so from here to here is also going to be 6. So I can add those two together then to get a total of 9 feet. So this other diagonal then is going to be 9 feet long. So I have my base 1, 6. I have my base 2 now of 9. Now I need my height. And again, the height's not given to me, but it does create this nice little right triangle, so I can use Pythagorean theorem to figure out this height. Now I recognize this as a 3, 4, 5 Pythagorean triple. 3, 4, and then 5, so I know this is going to be a 4. If you need to use Pythagorean theorem to calculate that, go ahead, but if you recognize a triple, it makes it a little bit easier. So now I know all my values, so I'm just going to substitute them in. So this is 1/2. The height, which is 4 feet. Why does that keep skipping on me? I don't like that. Let me be a little bit more. 4 feet times one base, which is 6 feet, plus the other base, which is 9 feet, and so I have my formula. So this is an even number, so I can go ahead and take half of that right here, so that leaves me 2 feet. And then 6 feet plus 9 feet is 15 feet. I'm not multiplying, so I don't change the units here. Adding them are like adding like terms, so we don't change that. So then we have 2 times 15, which is 30, and then feet times feet, which would be then feet squared. So the area of this trapezoid would be 30 feet squared. Okay, so again, choose the formula, figure out what you need, and then substitute in. Let's take a look at number 9 over here. No, number 10. Now again, as I look at the figure, I choose my formula. I recognize this as a trapezoid, so I'm going to use 1/2 the height, base 1 plus base 2. As I look at my diagram, I have one base here at 15 feet. I don't know what the other base is, so I'm going to have to figure that one out. And I don't know what the height is, so I'm going to have to figure out that one as well. Well, again, as I notice this is kind of triangular over here, if I draw my height straight down here, that creates this nice little triangle, and then this is my height. And again, it also creates a rectangle on the side here. Now here's where you have to be careful. The 15 goes from here all the way over to here. So I'm going to need to figure out what this is and subtract it from 15 in order to get this length here. Okay, so everything is based on this triangle right here. And because they give me an angle of 60, I know I'm dealing with a 30, 60, 90. So I need to go ahead and remember my relationships and go ahead and figure that out. My hypotenuse is 8, so I multiply the shorter times 2 to get the hypotenuse. So I'm going to divide by 2 to get this shorter leg. So 8 divided by 2 is 4. So that means this shorter leg here is 4. Then if I multiply this by radical 3 to get the longer side, that gives me my height of 4 radical 3. So now I have my height. And then I can use 15 minus 4 to get my other base, so that's going to give me a base of 11. So now I have all my values determined. I can substitute them into my expression. So I have 1/2 the height, which is 4 square root of 3 feet, and then one base is 15 feet, plus another base of 11 feet, and then I can do my arithmetic. Because this is even number here, I'll go ahead and take half of that, so that makes that a 2, so that gives me 2 square root of 3, 2 square root of 3 feet. And then 15 feet and 11 feet is 26 feet. Adding those together, and now I can multiply. The 2 times the 26 is 52, square root of 3, feet times feet is feet squared. So it says to leave my answer in simplest radical form if I don't come up with an integer or a whole number. So my answer then would be 52 radical 3 feet squared. And we check our answer. Okay, so again, we start with the formula. We know what we're looking for in the diagram. If we do that, then as we look at the diagram, we find the pieces that are there, and the ones that aren't there, we use what we know before to go ahead and calculate some of those things that we need. Let me do a couple of examples here where we use rhombus or kite so that you can see how those work. As I look at this diagram here, this one's kind of simple, so I'm going to skip that one. This one. So we're going to take a look at a couple rhombus examples. A rhombus, as I look at the figure, I see it's a rhombus, so I have to remember my formula. 1/2 the diagonals multiplied together. So then as I go to my diagram, I'm looking for the length of the diagonals. This length here is 8. I need the entire length, and I know that the diagonals bisect each other, so this other side is 8. So 8 and 8 is 16, so one of my diagonals is 16. So that's 1/2, and then one of my diagonals is 16 inches. The second diagonal needs to go from here to here. Let me change colors here. Needs to go from here to here. Again, I know these are perpendicular, so this creates a right triangle. So I can use Pythagorean theorem then to figure out this side so that I can figure out this diagonal. Okay, so this is an 8 because both of those segments are the same. So again, I notice this as a Pythagorean triple, or a multiple of a triple. 3, 4, 5 is a triple. So this is a 4 multiplied by 2. This is a 5 multiplied by 2. So this is going to be a 3 multiplied by 2, or a 6. And again, if you recognize the triples, great. If you don't, just use Pythagorean theorem. 8 squared plus x squared equals 10 squared, and solve it, and you'll get a 6. That's just half of this diagonals. I add double that, or add it to the other side, so I get another diagonal that's 12 inches in length. Now that those values are substituted in, I can do the arithmetic. Half of 16 is 8, and then 8 times 12 is 96. And then inches times inches is inches squared. So I have a total area of 96 inches squared. Okay, I'm going to do one more example down here, number 16. Again, as I look at the figure, I recognize it as a rhombus, so I'm going to use my formula. So I'm going to write that out. 1/2 diagonal 1 times diagonal 2. I need to figure out the diagonals. I'm already given 1. That gives me a dimension of 6, so one of the diagonals is 6 meters. So I'm going to go ahead and substitute that in. And now I need the other diagonal. Well, the other diagonal is not even drawn, so I'm going to have to draw that in for myself. So when I draw that in, what does that do to this diagonal? Well, it cuts it in half, so that makes this a 3. Okay? And again, this is a right triangle, and so I'm going to use, I need to know what this is, so I'm going to use Pythagorean theorem. Again, I recognize a 3, 4, 5, because 5 is here, 3 is here. This one's going to have to be a 4. So I know that this is 4, and then 4 doubled for the diagonal is 8. So this diagonal is going to be 8 meters in length. And again, if you don't recognize the triple, just substitute in Pythagorean theorem and calculate it that way. So I'm going to go ahead and take half of this 6, which is 3, and then the 3 times the 8 is 24. Meters times meters is meters squared, so I have an area of 24 meters squared for this rhombi, a number 16. A rhombus, it's not plural, rhombus. Okay, so again, hopefully those were helpful. Choose the formula, look at the diagram, see what you have, see what you need, and then if you don't have what you need, you're going to create these right triangles and use Pythagorean theorem, as you saw many times, or maybe 30, 16, 90, which we did once, and then in future lessons, if neither of those are available, then you can go ahead and use trigonometry, sine, cosine, or tangent to figure out the value that you need to go into your formula.